Today we will talk about how to declare a collection of objects using arrays, say 5 ints, 10 doubles. To declare an array of n elements with type t, we can write type t, then space, name of the array with the size n inside the square brackets. Here we use int array as an example and declared an int array named A1 with 5 elements. To access one of these array elements, you should use the same square bracket syntax that you use to define the array. So here A10 is the first element, A11 is the second, A12 is the third, and A14 is the last. It's very important that we always remember C++ arrays is zero indexed, meaning the first element index is always 0. Because we have int array A1 with 5 elements, so the last element is 5 minus 1, which is 4, and we should never access A15. To go through and print every element in an array, the easiest way is using the range-based for loop. Here A1 is the range, and int x refers to every element in the range. Let's come out the remaining part of the program. Click compile and run. Great. It prints out the content of A1 as expected. An array can be initialized with a list of values. We can specify the size of the array in the square bracket, or we can leave it as blank, as we did for A3. So the compiler will do it for us automatically. Both A2 and A3 will have exactly the same elements as the int array A1, and here we will use a more general for loop to print out all the elements inside these two int arrays. Within the for loop, there are up to 3 statements we can add. That is initialization, stopping condition, and step, which is separated by the semicolon. Any of these 3 statements might be empty. The initialization runs only once at the very beginning, just before the first iteration. Here we define the index counter int I and initialize it to 0. The stopping condition will be tested before each iteration. So if the condition is false in the first iteration, the statements will never run. At the end of each for loop, we will run the step part. Because we want to go through all elements in the int array, and we can do I equals I plus 1 to increase I by 1 unit at each time. But more commonly, we use the auto increment operator, that is plus I or I plus. These two are the same inside the for loop, but when we assign them to another value, they are different, as we will discuss them later. To summarize, in the for loop, at the very beginning, we initialize the counter to the index we are interested in, and then at each iteration, we test the stopping condition. If it is false, we stop immediately. If it is true, we run the statements or the code block here. After that, we run the steps and then continue with the next iteration. Let's click compile and run. And we can see A1, A2, and A3 will output exactly the same elements, which is as expected. We need to note a few things here. So if we specify an int array with size 5 and only provide the first 3 elements, then the remaining two elements will be filled with 0. So A4 will be equivalent to this one in our case. However, if we supply more elements than the number specified, it will cause an error. Here, if we uncomment this line, A5 is specified with size 5, but 6 elements are provided. Let's click compile, and we will see the error message. Let's comment out this line and compile again. And we can see now the error message is gone. Here, the first for loop will still output all elements of the interarray A4. But here we used this form. It did exactly the same thing as these two expressions, which increase I by 1 unit at the end of each iteration. The good thing about this form is we can easily change the value here, say from 1 to 2, so we can perform some operations on every second element of the array. Let's click compile and run. We can see the same output as before, and for A4 it's 1, 2, 3, and the remaining two elements are 0. And it print again with only the every second element, which is 1, 3, and 0. The last bit we would like to discuss is the auto increment and decrement operator. The increment operator is ++, and we already mentioned that it means increase by 1 unit. However, if the operator is in front of the variable, then the operation is performed first. So we increase I1 by 1, so I1 becomes 6. And then the resulting value is produced, which is 6, and 6 is assigned to I2. If the operator is after the variable, then it will generate the resulting value first, which is the value of I1. So now I1 has a value of 5, it will be assigned to I2. So now I2 also has a value of 5. And then the operation will be performed, which will increase I1 by 1. Hence, I1 will have a value of 6 afterwards. The decrement operator is minus, and it means decrease by 1 unit. Quite similarly, if the decrement operator is in front of the variable, then the operation is performed first before the resulting value is produced. So I1 and I2 will have exactly the same value, which is 4. If the operator is after the variable, then the old value of I1 will be kept, so I2 will be 5, and then the operation will be performed. The resulting value of I1 will be 4. Let's click compile and run. And we can see the same output as before, and the new results will match what we have just discussed. That's pretty everything we would like to discuss for today, and thanks for watching. See you in the next one.